So I have a command line tools that work with SDK, that work with Unicity tokens, that allows you to mint tokens and basically define the reason why you're meeting it and put all kind of data in. It allows you to send tokens, it allows you to receive tokens, and it allows you to verify tokens. And also it allows you to work directly with aggregator infrastructure. So you can send the request commitment basically, and then get the commitments. I'm going to show you how to work with tokens now. So let's say you want to mint something, right? So what mint allows us to do? Mint command allows us to define the endpoint of aggregator. This one explicitly. By default, it should use production mode. These are preset types of tokens. By the way, we have to discuss. I have a little bit different idea in mind what this type of token should be. Currently, we have NFT, alpha/UST, USD, tethered coin in Unicity, and euro tethered coin in Unicity. These are token types. What else? We can define explicitly nonce, not then it will be auto-generated. We can define explicitly if it's unmasked predicate, reusable address. We can define explicitly the token data we want to put inside the, inside the token object. So it could be either JSON or text. It will be stored in token state. Then we can define the list of coins we want to mine. But here, keep in mind that if you create a list of coins inside the Unicity token, in the generic SDK and generic command line, if you don't specify exactly, it's not going to verify the origin of coins. It just doesn't care. It's just some piece of data it ignores. But for the moment, at the moment, I'm in the process of basically I already made it. A flow for mining the Unicity coins and mining them directly into Unicity tokens. So you mine a block, you can create token that is being referenced from the block that you mine. You create a token with this ID, and you can put the coin data, like 10 Unicity coins or something like that, depends. And then the extra procedure will verify the origin. It will ask the blockchain for the block that contains a reference to Unicity, basically to the hash of Unicity of token ID. And if it fits, then yeah, it's a valid proof that you have mined a certain amount of Unicity coins into this specific token. Well, the problem now with this is that we need to, with Martin, to work a little bit on the possibility to put any kind of reason into Genesis reason field. Currently, you can only put splits, which is quite easy. So we have a little bit to modify things here. But the major thing is like this: we are splitting concerns. So in general, SDK on lowest level only should verify the mining itself. It should verify the ownership change when you do token transactions. Correct? And you should verify that the Unicity, like, no doubles can't happen. But all this application-specific data, including the coins, splits, and what mining and whatnot, maybe some other more specific kind of cases where you want to run some specific logic and tokenize state of your, let's say, application or agent inside the token. It's not being verified by SDK on the lowest level. It's going to be verified by other person. So this is the situation with coins. You can explicitly define token ID if you wish, or it's auto-generate. Token type, well, it's also set in preset, or you can put your own as a hex string. You can explicitly define sol, otherwise it's all randomly generated. You should specify it in which file you want to record your token that you mine, data structure that you want to mine. So you can save and auto-generate the file name. This is for mostly for testing purposes. If you don't want to use complex secrets, just use simple secret words, short words, and call concept unsafe secrets, so it will allow you to do simple secrets. And this is a specific thing, so Unicity Mind. So it means that you should, when you want to mint a token with mined coins, Unicity coins, you should tell exactly which block height it was mined. And this block must contain a reference to the hash of a token ID that you're going to, where you're going to basically mine these or create these Unicity coins. This is a reference Unicity URL. This is a reference to the blockchain endpoint, not the same as aggregate. It's important. So we need to get this block headers from there. This is for testing purposes, like local Unicity mint. Also, this parameter you may ask not to verify basically the validity of the token ID into which you mine Unicity coins match what you have in the block header. This is not safe, but for instance, you might want to skip this kind of verification by whatever reasons. All right, so let's mine a coin. It's enough token. Let's mine some coin. Token. Coin mining is not fully working yet. My secret is, let's say, 1. So what I've done here, I made it in such a way that I mined it. I registered it with a Unicity aggregator or Unicity Oracle, whatever we call it. I got from it the proof of single spend to the proof that this token ID was not mined before, and now it's mined. So you can see data structure here. So you have version, you have genesis, in genesis you have data. When data is empty, reason is null, it's fine. It's direct mining. So this is an address corresponding to secret one. And public key. This is rent sold, token ID, token type, and things like that. So not quite nothing super interesting. And this is something that we got from Unicity Oracle. Should be fine. This is transaction hash, Unicity certificate, upload it like this. In state, we have nothing, data is empty. This is our predicate encoded like hex time, stuff like that. So I can even run the verification now, just for fun. And we run verify token. Yeah, so let's just set it to file or file or something like this, right? Where did you store the token? This? Oh, okay. It's a local exploit. We can ask to verify that the token has been spent or not. Skip network verification if needed. Oh, I guess we have everything. So let's verify it. So what it says, so it shows a quite comprehensive analysis of what we have done. The summary is like this. Token format is TXF version 2.0, has genesis true, has state true, has predicate true, proof structure valid yes, SDK compatible yes. So like any application that is using SDK developed by Marty should basically chew it nicely. Cryptographic proofs valid yes, and you have all kind of other interesting stuff. Okay, so let's do next thing. Next thing is sending token. We want to send it to someone, but in order to send it to someone, we have to generate the address, right? Yeah, you have a bunch of things. The address depends on your token type, right? And you set it text implicitly or explicitly. So we have nonce, because if it is mask address, right? Okay, so see secret tool. So this is our address. That's where we want to spend our coin, right? I want to send my token. So you have lots of parameters here. You can say the input file. You can indicate the recipient. You can indicate if you want to include some specific message into the transaction. The recipient data hash. You don't know what the recipient data will be in general case. but you should get from the recipe in the data hash. This is again the same story as this endpoint, where we get the aggregate from local, or it's production endpoint. By default, it's production. Submit now. We have two ways of doing it. Either when I generate a transaction, I also can submit right away to Unicity aggregator and get the proof, or I just store a commitment in the TXT file and let the recipient deal with this. The output file, I'm going to output stuff, then save. If I don't care about the output file name and some bunch of other things. Skip validation if you don't want to, yeah. If you really don't want to verify. I remember what it was doing. Oh yeah, I guess you were signing the token, but not yeah, you're not verifying whom it belongs to. I needed this to make sure that the recipient SDK will catch inconsistency in the token that someone else, but not you, was spending the token on your behalf. Of course, someone else cannot generate the correct request ID for you, so it's still safe. By the way, this should fail if I try to spend the same token in the line, because this token has been spent the previous. Let's see. Okay, submit now, save secret, blah, 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 blah. Prompts. So secret one, right? Okay, prompts. Oh, okay, it's waiting for authenticate. Okay, everything is cool. So we are golden. We basically create the transaction. So we have one transaction. Transactions, it has all the necessary proofs, stuff like that. So let's verify it, okay? Verify token.
Did it finalize the transaction?
Yes. The next planning, when this is all done, yeah, I'm still need to work a little bit more on this command line tools. So it also supports full resolution of public code finalization of a transaction. So we could also see the final state, final current state, including the new predicate in the token data structure. And then I need to include name tag support. I need to include automated storage and transmission of a token file, TXT file, via, let's say, Nostr network. Pavel has implemented Nostr-based network files. So you don't just copy the file, TXT file, and deliver it by yourself, but the system, like for user simplicity, it could be done automatically. And when everything works, we'll basically move this implementation to a web environment, so incorporate it into WebGUI wallet that we have right now. But this is work for a few weeks, I suppose.